The agenda that we're going to cover over the next hour, going to talk about a project development and execution process, kind of outline a process, and then really the focus today is going to be on decision and risk analysis. Making good decisions. We'll be talking about tools such as decision hierarchy, strategy table, influence diagram, tornado chart, decision tree, S-curves. We'll get into a lot more detail on all of these topics. And then finally, I'm going to summarize by telling you what some of the key takeaways from this presentation are. I thought I'd just kind of share with you the kind of projects that we have worked on in the energy business. So the slide shows offshore platform. This is a platform in the Newfoundland area in Canada, designed to withstand impact of an iceberg, a multi-billion-dollar project operational for several years now. It talks about a floating production, storage, and offloading system. This ship is the size of a football field, and really it's kind of stationary, anchored in the ocean, produces oil, and small tankers come to take the oil away. So it's really a stationary facility in the ocean. That's about an oil sands truck. This truck, just to give you the size of the equipment, weighs 400 tons empty, which would be the weight of 200 full-size cars. It takes 400-ton load, and so the total weight of it is 800 tons. The person who's standing there is about 6 feet tall, and he's about half the size of the tire. This slide talks about the oil sands shovel and truck, and as you can see the shovel, you might be able to see some of the people standing here, up here, and just showed you the size of the equipment. The shovel scoops up 100 tons per scoop, and it dumps it into a truck. So 4 scoops, it fills up a truck. Every few minutes, this truck dumps the material into a crusher, and the oil is extracted from the sand and shipped out. And the huge pieces of equipment that you can see here. This operation happens 24 hours a day, 7 days a week, 365 days a year. The next is a liquefied natural gas tanker. You can see the helicopter trying to land on the right-hand side. Again, the size of this tanker is football field. The gas is liquefied to minus 160 degrees so that it can be condensed and transported. This project is in Australia. It transfers the gas from Australia to China, Japan, Korea, several countries. This project has started off almost 20 years ago. Cost was $54 billion with a B, and took from the time the gas was discovered offshore in the ocean till the project was developed, executed, and operated about 20 years. Last slide talks to you refinery and petrochemical complex. This is typical where you get your gasoline, jet fuel, diesel, and of course hundreds of petrochemical products ranging from rubber, plastics, polyester in your clothes, etc. It goes on and on. So with that kind of a backdrop, let's talk about a project development and execution process on slide 16. That provides effective communication between decision makers, multifunctional project team, and stakeholders. The project development execution process, this is a process that facilitates optimal use of resources over the life of an asset or project to maximize value. And really the two desired outcomes from this process are to make good decisions, so select the right projects first, and then execute these projects with excellence. So what we're going to focus on today is making good decisions. So how do we select the right project? That's the focus of the discussion today. To expand a little more on this process, slide 18 shows the project development and execution process. Phase 1, identify and assess a business opportunity. You clearly frame the goal. You're looking for strategic fit, etc. You're typically done very little engineering, about 1%, and you'll come up with what we call a phase 1 estimate, which would have a high contingency and a wide accuracy, both on the cost estimate and schedule. This is Diamond 1, and that's kind of a gate where you meet with your sponsor and you decide whether is there a viable business case to proceed forward. And if so, you move into phase 2. You select from alternatives. Doing nothing is an option. Building something new is an option. Expansion is an option. Acquisition, divestiture, anything goes in phase 2. And the goal of phase 2 is to identify a preferred alternative by the end of phase 2. We'll have a phase 2 estimate at the end of phase 2, and this will have what we call a moderate contingency and a moderate accuracy. By the time you come to the Diamond 2, you have selected an alternative. Meeting with the sponsor, if the project looks viable, you go into phase 3, develop the preferred alternative for full funding. This is really going to fully define scope, refine the estimate. You've done about 25% engineering on our type of projects, and you come up with a phase 3 estimate, which is you're trying to be within plus or minus 10% accuracy if you can. And so when you go to the phase 3 Diamond, which is the final investment decision, this is where you're really making the commitment for the big money. Again, phases 1, 2, and 3 are known as front-end loading or planning phases, and then phase 4 is the execution phase. This is where we'll do detailed engineering, procurement, construction, etc. for our type of projects. And the goal of phase 4, again, having the discipline to not have scope changes creep up in phase 4. Minimize changes and look for a project review at the end of phase 4, have an operable asset turned over at the end of phase 4 that really kind of meets your safety, costs, and schedule targets that you establish in the final investment decision document. And then phase 5 is operate and evaluate, take lessons learned, both good and bad, from the project and apply those to future projects. So really a straightforward process. It's just having a discipline. And one of the things that I've seen happening in the good companies is starting in phase 1, we assign a project sponsor, and the sponsor stays on the job throughout the project and is actually called for a look back about 1 to 2 years after the project is up and running to see if the project delivered business results. So bringing accountability into the process. And also holding key project team members constant throughout phases all the way through phase 4 so that you have continuity of personnel, the key players on the project. With backdrop, let's get into the decision and risk analysis. We make informed decisions on projects. The decision risk analysis process, slide 20, compares alternatives, quantifies risk and uncertainties, and compares financial outcomes. Ultimately, everything comes back to money, so we're going to talk about net present value, rate of return, payout, etc. On every project, we kick off the project team at the beginning of phase 1 with what we call a brainstorming sessions to talk about issues. And these issues then are sorted into 4 buckets. They could be decisions. Examples, should we build a plant? Should we acquire a competitor? Should we sell the asset? You look at uncertainties, like in our business, price of oil or gas, margins, capital cost. Just to give you a little bit of a flavor of what has happened in the oil industry, price of oil in the last few years has dropped from over $140 a barrel. It went down to $26, and now it's hovering around $50. So you can imagine the uncertainty on the prices.